Hello guys, we're going to talk about types of matter today, so you should have these notes in front of you. They're page 3, and you should have a highlighter and something to write with. If you don't have those things, go ahead and pause this video and go grab them and then come back. Okay, let's jump right in. What is matter? Matter has mass and volume, and mass is the amount of matter in an object, okay? We measure mass in grams or kilograms. Volume is the amount of space an object takes up. Okay, this is typically in liters or milliliters. Okay, elements, compounds, molecules, those are all examples of matter. Okay, so let's talk about what's the difference between an element, a compound, and a molecule. Elements. Elements are only one type of atom. They can exist as atoms or molecules. So an example of an element, neon is an element. Anything you can find on the wonderful periodic table, those are all elements. Okay, silver, Ag, that's another great example of an element. Now there are 7 diatomic elements, so let's write those out. You should be writing everything that I write. Don't forget that. Okay, so bromine exists in pairs. So you'll never see one bromine floating around by itself. It always exists in pairs. If it's not already in a bond with something else in the atom, then it's going to, if it's not already in a compound bonded to something else, then it's going to exist in pairs like this. Okay, so that's a diatomic element. These are our other diatomic elements. There's 7 of them. So let's write them all down so we have them in our notes. And they spell out Brinkelhoff. That's how I remember. These are our diatomic elements. Okay? Our Brinkelhoff elements. All right, and another way that I remember them is they kind of form like a 7 on the periodic table. And then hydrogen is another one. So hydrogen and then these 6 right here, those are your diatomic elements. Okay, they are never by themselves. So when you see this, that is considered an element because it has only one type of atom. Okay, now a molecule. So these are technically elements, but they can also be considered molecules. It's when 2 or more atoms are chemically bound together. Okay, 2 or more atoms are chemically bound together. They can be the same or different. Okay, same or different types of atoms. So an example of a molecule, H2O, that's a molecule. CO2, that's a molecule. These are all molecules, so like H2, that's a molecule of hydrogen. Okay. Compounds. Compounds are 2 or more different elements, okay? 2 or more different elements. So, I mean, there's endless number of examples I could give you, like iron 2 chloride, that's a compound. H2O again is a compound. AgBr, that's a compound. Those are just examples of compounds, okay? So let's do some practice. It says, identify whether each is an element or a compound. This has 2 different things stuck together, so that would be a compound. So I'm going to put C for compound. This is carbon, and there's 60 of them stuck together. Okay, well, it's just carbon. There's not 2 different types, so that's just an element. O2, same thing. That's a diatomic element, so it's not a compound because it doesn't have 2 different things, so this would be element. This clearly has more than one type of element bonded together. That makes it a compound. Same with this one, compound. And this one is 8 sulfur stuck together. So since they're all sulfur, it's all the same thing. That's going to be element. Okay? Alrighty. Properties of elements and compounds. Okay, so elements can't be broken down using chemistry. Okay? You can't break an element down any further than it's already broken down. I mean, technically, if you want to get into nuclear chemistry and stuff, splitting an atom is possible, but for all intents and purposes in this class, for 8th grade chemistry, we're going to say you can't break anything down smaller than an atom or an element, okay? The identity of an element is determined by the number of protons in the nucleus, and isotopes, do you guys remember that word? Isotopes are determined by the number of neutrons in the nucleus, okay? So, for example, if we're looking at lithium on the periodic table, this is what it looks like. It has an atomic number of 3. This is its atomic mass. Okay, so this is lithium, right? Lithium. Again, make sure you're writing everything I'm writing. So lithium, because it has atomic number 3, it means it has 3 protons, right? Proton, proton, proton. 3 protons in its nucleus. So now, we don't know. So some lithiums are going to also have 3 neutrons in the nucleus. And then here's all the electrons out here in the electron cloud. Now, there might be another lithium that also has 3 protons in the nucleus. All lithiums have 3 protons. If it didn't have 3 protons in it, it wouldn't be lithium anymore, okay? Because its atomic number is 3, that means it always has 3 protons. But there are some lithiums out there that have 4 neutrons. Okay? That have 4 neutrons. This is also lithium, and these are its electrons out here. This is also lithium. These are both lithium. They're both lithium. And because they have different numbers of neutrons, their atomic masses are going to be different, so they are going to be considered isotopes of each other. These are 2 different lithium isotopes. They're both lithium because they both have 3 protons, but their number of neutrons might be different, and that's what makes them isotopes. Okay? We'll talk a little bit more about that when we get into our periodic table unit. Okay, compounds can be broken down using chemistry. So if you do a chemical reaction or a chemical change, you can break compounds down. That's what this is right here. You've got, what is this, glucose and oxygen. It's breaking down to make carbon dioxide and water. So 2 completely new compounds. You can do that using a chemical change. Okay, let's talk about mixtures. Mixtures contain 2 or more substances. Okay, there are homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures, let's highlight those. Homogeneous and heterogeneous. Homo means same. Okay, homo means same, hetero means different. So homogeneous solutions are the same throughout. 1 or more substances dissolved in another substance. A homogeneous solution, or homogeneous, some people say homogeneous. A homogeneous solution or mixture is also known as a solution. Okay. Heterogeneous mixtures are mixtures where the substances remain physically separate. Okay, the individual substances remain distinct and separate. Oh, separate, not separated. Separate. Okay. So let's look at some examples. Look at the images to the right. Label each as either an element, a compound, or a mixture, and then we'll circle the pure substances. Okay, so let's look at this first one. Is this an element, compound, or mixture? I would say this is an element because it's not bonded to anything. They're just free floating. This, I would say, is a compound because it has 2 different types of elements bound together. Okay, this is an element, and the different colors represent different types of elements. So if this is an element and this is a different element, they're not chemically bound together because they're not touching, but they're mixed together. I would call this a mixture. This one, I see an element and then I see a compound and they're all mixed together, so this one would be a mixture. These are 2 things bound together, however, they're the same element because they're the same color. So this would be like a diatomic element, so that would be E for element. And this one would be a compound. Oh, nope, just kidding. It almost fooled me. Do you see how this is different from this? These are 2 different things. This is a compound with a black and a white. This is a compound with 2 whites and 1 black. So these are, because they're 2 different types of compounds, this would be a mixture. Okay. Then it says to circle the pure substances. Okay, so anything that's not a mixture is a pure substance. So this is a pure substance, this is a pure substance, this is a pure substance. These ones that are mixtures are not pure substances. Okay. Okay, it says draw 3 particle diagrams. Okay, so let's draw 3 boxes. consisting of H2, so this one's going to have H2O, this one's going to have H2, and this is going to be a mixture of H2 and H2O. So let's kind of decide what each particle is going to look like. So I'm going to make my hydrogen just a circle like that, and my oxygen, I'm going to make a purple circle like that. That's oxygen. Okay, so if I'm going to make H2O, so each diagram needs at least 4 molecules. So H2O is going to have 2 H's and 1 O. Like that. Okay, so there's an H2O molecule. Here's an H2O molecule. Here's an H2O molecule. And here's an H2O molecule. Okay? Alright, so there's my H2O. H2 is going to have 2 little white ones stuck together. That's an H2. That's an H2. That's an H2. That's an H2. Now, if I want to make a mixture of H2O and H2, that means I need to have an H2O here, and maybe an H2 here, and an H2O here, and an H2 here, and they're all mixed together. Okay, so you need to be able to identify particle diagrams like this and understand these representations. Things like this, hint, hint, tend to show up on things like quizzes, tests, pre-comps, stuff like that. Okay. Okay, let's flip over. I love this kind of flow chart. And if yours didn't print super well, then maybe outline it. So matter is broken up into 2 things, pure substances and mixtures. Pure substances are broken down into elements and compounds. Mixtures are broken down into homogeneous and heterogeneous. Okay, and a homogeneous mixture is also known as a solution. A heterogeneous mixture is also known as a suspension. So let's talk about those here real fast. Okay, so homogeneous or homogeneous mixtures have 2 parts. There's going to be a solute and a solvent. Solute, solvent. The solute is the substance being dissolved. The solvent is the substance doing the dissolving. So the solute, there's always going to be less of it. The solvent, there's always going to be more of it. And if something is aqueous, you'll see a little parentheses with an AQ. You probably saw that last year. Then that means it is dissolved in water. That's what aqueous means. Some people say aqueous. Some people say aqueous. I say aqueous. I don't know. That's just the way I learned it. Okay, practice. Identify which is the solute, or solutes, and which is the solvent. Okay, here we have saline. Saline is basically salt water. So in saline, we have this much salt and this much water, where which one is my minor component? My minor component is my solute. So because there's less of the salt, this one's going to be my solute. And this is my major component, the one that there's more of. So that one's going to be my solvent. Okay? This one, my major component, the one that there's the most of, that one's going to be my solvent. So this is nitrogen. This is my solvent. And the other things are going to be solutes. Okay? Alrighty. Let's talk about suspensions. What's a suspension? So we have solutions up here, just so we kind of organize it, and we have suspensions right here. Suspension contains large particles that settle out of a mixture. Okay, so a heterogeneous mixture is a suspension. Okay, so examples of suspensions, things like dust in air, because over time the dust will settle onto the ground. A mixture of sand and water. You can shake up a mixture of sand and water, but it's going to eventually settle, and the sand's going to sink to the bottom. If you can see the individual particles, then it's a suspension. So let's practice. Identify each as a solution or a suspension. Muddy water. I would say that's a suspension. Okay, there's chunks in it, probably of stuff. It's not the same throughout. Atlantic Ocean. Okay, that, could be debatable. If you're looking at it as a whole, I mean, there's all sorts of things in there. But if I just took like a sample of the water, it would probably be more of a solution because it's just salt water. Okay. Now, if there was like all this nasty floaty stuff in there, then you could technically classify that as a suspension. But It kind of depends on your sample size, right? Rubbing alcohol would be a solution. Rubbing alcohol would be a solution because it's alcohol dissolved in water. It's isopropyl alcohol dissolved in water. Okay. Okay. Draw a particle diagram. So we need to make two particle diagrams, and one's going to have a heterogeneous mixture of water and argon, and then the other one's going to have a homogeneous mixture of copper and zinc. So here's particle diagram 1, particle diagram 2. Okay, so the first one, it needs to have water and argon. So let's represent water the way we did before, H2O. So this will be our water. And then argon, let's just come up with a new, completely new symbol, like a star. That one will be argon. Okay, so this is going to be a heterogeneous mixture. So if it's a heterogeneous, so this one's going to be heterogeneous. This one's going to be our homogeneous. So our heterogeneous mixture, that means that they are going to kind of separate out. So let's put our argon sinking to the bottom and our water. Okay, so it's not uniform. It's not uniform. You can see the separation there. Now, a particle diagram of copper and zinc that is homogeneous. So let's say that, because this is a new one, let's just say copper is open circle and zinc is the closed circle. Now, if it's homogeneous, it's going to just be kind of, everything's going to be distributed throughout nice and evenly, all mixed around in there, kind of like that. Okay, so do you see the difference between a heterogeneous? There's like a separation between the two. Homogeneous, everything is distributed throughout evenly. Okay. All right, there's the end of the notes. You guys have an assignment to do. Hopefully you wrote down everything I wrote down. Good luck.